Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. Alright, for this problem, first we record that since the rooms are not identical, that means we can actually distinguish them. So we're just going to use some kind of rectangles to specify what the rooms are. So the first two are 2-man rooms, the other two are 3-man rooms. So we're just going to line up all the 10 friends. So let's say I call them A, B, C, D, E, F, G, H, I, J. So we're just going to use a strategy to book them in the rooms. If we order them in any order and we demarcate them according to the rooms they are facing at this moment, whereby the first two going to the first room, the next two to the second room, the next three to the third room, and so on, then we're going to have an arrangement of them in a room. Okay, but now this will not be a one-to-one correspondence because, for example, if we had B before A, they will still both be in the same room. So the order in which they enter the room and things like that were not specified. It's not important. So this will be the same. Both of these will be the same arrangement. This means we have to probably must have double counted if we are just looking at different ways of arranging them initially before placing them in the rooms. So we have to take note of all those multiple counting, and the countings are going to be independent. For each of these we could permutate them in different ways, and it's not going to affect others, and they'll all be in the same arrangement of rooms, right? So here we have different arrangements like E, G, F, and so on, and here the same, we have multiple arrangements. Okay, so since they're independent, it means that we can use a multiplication rule to make up for it. So whatever the number we are interested in is, let's say we call it X, then X will give us the initial arrangement in the rooms, meaning that if we permutate them according to what I just did here, then we're going to get the total possible ways they can actually form a normal line, right? So just going backwards. So this means that since they are all independent procedures, the first one we have 2 ways. We have 2 times 2 times. So for 3 objects, permutating that is just 3 factorial, which is 6 times 6. So this will just correspond to arranging them in some file, and that will be permutation of 10 objects, which is actually 10 factorial. So to get X, we just actually divide this and we are good to go. So or we could just see this as permutation with repetitions, and that's also fine. So either way we get this, and 10 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10, divided by 2 by 2 by 6 by 6. So 6 can cancel out here, 3 can cancel out here, remain 2. These 2 can cancel out with 8, and we are left with 2 by 4 by 5 by 7 by 9 by 10. And pairing 2 and 5, we get another 10. So just 4 times 7 times 9, which is 252 times 10 times 10. We just add 2 more zeros, and that means the right option here is option A. Alright, I hope you enjoyed this, so I'll see you in the next one.